Momentum number 2. A one-way train, mass 500 tons. Metric tons, that is. TON is imperial ton. Well, they're both approximately the same, both about the amount of weight as a small car. Anyway, this train has 500 tons. Going, 1 ton is a small car, going 100 miles per hour. Okay, that's out of control, really. That's miles too fast for a train, unless it's a super fast train, which there are some. Crashes into the back of another train. Whoops. Mass, 700 tons, going the same direction at 50 miles per hour. Oh, phew, at least it's going the same direction. Not so much whiplash. The total momentum is 500 tons times 100 miles per hour plus 700 tons times 550 miles per hour. Wow, okay. Mass after the crash. Okay, the mass of 1,200. 500 plus 700 is 1,200. Okay, so this is 5 with 4 noughts. 1, 2, 3, 4. Plus 7 times 5 is 35 with 3 noughts. 3. Okay, so that's 8, 5, 1, 2, 3. Tons, miles per hour. Whoa! Okay, I done that one in my head. Momentum before equals momentum after. Yeah, the two things you need to know about momentum is momentum before equals momentum after. It works for the smallest particles and the biggest of black holes. It's one of the very few laws that seems to work everywhere. And also momentum is the speed times the mass, or the speed times the weight, which either of those are good. 100 miles per hour times 500 tons plus 50 miles per hour times 50 miles per hour times 700 tons equals V times 1,200. Oh yeah, because the amount of tons is the same afterwards. We've just got to calculate the velocity of the combined thing. So, okay. So that, well, I've worked that out. 35,000, 35, 1, 2, 3. Add those two together, divide by 1,200, you get the velocity. Velocity after the crash equals, okay, down below, add those two together, you get 85,000. 85,000 divided by 1,200, it's going to be about 80 miles per hour, 70, 80, something like that. Part B, 800 tons, 120 miles an hour. 500 tons, 70 miles an hour. What will be the combined speed? Use the same method as you've used in A, that I've just shown you, to get B. Write the answers down below in the comments. The science of momentum is how crash scene investigators work out who caused the crash and whose insurance company gets the bill. This is kind of important. This is money. Okay, next one. A 500-gram ball, half a kilogram, 500-gram ball going 2 meters per second towards a foot is football is kicked by a 1 kilogram foot going, well, that's a bit much for a foot, but never mind, going 10 meters per second. I wanted to keep the maths easy. 10 meters per second. The foot hits the ball for half a second. How big is the force? Oh, this is about impact. Force times time equals the impact. The ball is going the opposite way to the foot, so the velocity is -2. Yeah, with the ball it's -2. We're going to take the foot wins, okay? Foot goes this way, ball goes this way, foot wins. So always take the one that's winning as the plus. It just keeps your maths easier. Otherwise you end up with loads and loads of negatives everywhere. Make all the masses the same units. So the ball is, oh yes, of course, because that's grams, that's kilograms. You got to make them the same units, otherwise you can't compare. 0.5 kilograms for the ball. Tip. Always write momentum before equals momentum afterwards. Tip 2, put the units in with the numbers. Absolutely. Oh, I think I'll have all this lot all moved over here so it gets underneath there. Momentum before. 10 meters per second for the foot. 1 kilogram foot. Minus 2 meters per second. That's the ball. Half a kilogram ball. Okay, so... the combined mass is 1.5 kilograms, and we don't know the velocity yet. Okay, So 1 times 10 is 10. Notice how the units all get together. Kilograms, meters per second. 2 times a half is 1. 10 minus 1 is 9. But that's going to be... That should be an x there. Times x. Oh, rather, let's be much more sensibly, v for velocity. Right, okay. Here we go. 1.5. We need to divide... Now, 10 minus 1 is 9. Equals 1.5 times what we're after. So, divide by 1.5 both sides of the equation. You'll get the velocity that way. Okay. Impulse equals force times time equals change in momentum. The ball goes minus 2 meters per second times 0.5 kilograms to plus 6 meters per second. Oh, this answer must be 6. Times 0.5 kilograms. Oh, yeah. And 9 divided by 1.5, that's 6. Right, okay, that's where that 6 comes from there. So we're finding out the change in momentum of the ball. Changes from minus 1 gram meters per second to plus 3. 6 times 0.5 is plus 3 meters per second. The change is 4 meters per second. That's the impulse. Time is half a second. The impulse is... half a second times the time and the force together to get the momentum change. Okay, momentum change is 4 kilogram meters per second. 4 kilogram meters per second divide by the half a second gives a force of how many kilogram? Kilograms. Force 8. Cool. And there's a second one to do where there's a foot coming along at 10 meters per second. And 1 kilogram foot is going that way, 10 meters per second, into a brick. Okay. At 0 meters per second. Use the same method as I did in C to work out D. What will be the force on the foot? Out. Much, much more than the force from the ball. And that's why you don't kick bricks. Because they give you so much force, it's painful. And E. A 10 kilogram bullet moving 200 meters per second hits a 70 kilogram man. What would be the combined speed? Oh, not very much. Actually, when bullets hit people in Hollywood movies... To make Hollywood movies exciting, they make the person go, woo, backwards, quite fast. In reality, no. Anyway, do this question. As usual, put your answers down below in the comments, and I'll mark them for you. Excellent. After I'm teaching in school, I'm in mid-levels in Hong Kong, I go to their pupils' homes to do home tutoring, science and maths, GCSEs, IBs, HSCs and A-levels. And I do Skype lessons for anybody who doesn't live in Hong Kong or doesn't live in mid-levels. If your mum or your dad wants me to help out with your GCSEs, IBs, HSCs, A-levels, SATs, then they should send me a message. Good luck, Gary, hk@gmail.com. Bye!